In this section, we are going to introduce the idea of hypothesis testing. So, hypothesis testing is a procedure that enables us to choose between two claims when we have variability in our measurements. We know that we expect our measurements and our sample data to vary. That is something that we expect to happen. But this helps us to kind of draw that line of how much variation is too much for us to start thinking that something interesting is going on here. The basic 4 steps of a hypothesis testing procedure start with stating a hypothesis, a claim about the world, and then this claim will be weighed against a neutral, skeptical claim or the status quo. Then you determine how you're going to use data to make your decision, and you make sure that you have enough data to minimize the probability of making mistakes. Collect your data next and compare that to your expectations. So that's kind of referring back up to that definition. So we're going to compare what we get to what we expected. And again, we expect it to vary a little bit, but did it vary too much? That will be kind of the question at that point. Once we make that comparison, we will finally state our conclusion. Do you believe this claim, or do you find that this claim doesn't have enough evidence to back it? Okay, so first let's start with the hypotheses. These are statements about population parameters, and that's really important. That's a key point that I want to make here, is that the hypotheses are always statements about the population parameters. So P, or for us, mu, that population mean, we're going to be hypothesizing about what this population mean is, not about the sample statistics, P hat or X bar for us, the sample mean. Why would we not write a hypothesis about a sample mean? Because we already know that. There would be no need to hypothesize about it. So I'm going to take a sample and I'm going to know exactly what that sample mean is. I'm going to calculate it. So there's no reason at all to hypothesize about what it might be. I know it. What we're doing is we're taking that sample mean and we're using it to hypothesize about the whole population, right? Those are the values that we don't usually know. Okay, so hypotheses is plural. There are 2 different types of hypotheses statements that we write. The first one is called the null hypothesis, written as H sub naught or called H naught. This is that neutral, status quo, or skeptical statement about a population parameter. It's kind of the general statement or default position that there is no relationship between the 2 measured phenomena. For us, the null hypothesis will always have an equal to sign. I like to call this one, or the word that I like to give that goes along with the null hypothesis, is boring. The null hypothesis is the boring statement. The null hypothesis says basically everything is as it always has been. Nothing interesting to see here, or everything we've heard about this topic is true. Okay, so it's the boring claim. Then you have your alternative hypothesis. That's H sub A, or simply called HA. This is the research hypothesis. This is a statement about the value of the parameter that you intend to try to demonstrate is true. I assign the word interesting to this HA hypothesis because this is one we're trying to show is true. This is the other side. This is saying, no, everything is not as it always has been. Something interesting is going on here. There has been a change, or it's not what we always thought it was. This alternate hypothesis can also take two different forms. It can be one-sided or two-sided. So one-sided has direction. It will either use a greater than or a less than symbol. While a two-sided alternate hypothesis simply claims that the null hypothesis is not true and uses a not equal to sign. So we can be specifically interested in seeing has there been an increase or a decrease, or is there higher or lower? We can be very specific, or we can be more general and just say, we just don't think this is true anymore, and we don't really care what direction it went. So wording here, we would have for the not equal to or different, or another word that we can add there is change or changed. Did something change? That would be a not equal to sign. Or we could have less than, smaller than, below, anything like that, or greater than, more than, and above. So watch your wording whenever you do these to be very, very careful about that alternative hypothesis symbol that you use. Let's go ahead and look at an example now. It says, suppose that McDonald's advertises that its ice cream cones have a mean weight of 3.2 ounces. A human server starts and stops the machine, so we might expect some variation in this amount. If we weighed all the cones at a particular store, would the mean really be 3.2 ounces as the company claims? So that's kind of our question. Do we believe what the company is claiming? Okay, let's say we sample 50 cones and we calculate the sample mean to be 3.68 ounces with a standard deviation of 0.3701 ounces. The question now is, do these observations support the claim that the mean weight is indeed 3.2 ounces? Or is there evidence that the mean weight is not 3.2 ounces? Write the H naught and the HA for this situation and say, is this one or two-sided? Okay, so I'm going to start with just labeling. I'm going to write H sub naught, and I'm going to write H sub A. Again, these are just the labels. That's not actually part of the statement. Now we need to write a null and an alternative. So the null is that always going to have an equal to sign for us. I'm just going to write an equal to sign. And also important is that we always are hypothesizing about the population parameter, right? So the population parameter, what we are making this statement about is mu, the population mean. And we are assuming the boring statement. We're assuming that it is what we've always been told. We've been told that the mean weight of the ice cream is 3.2 ounces. So mu equals 3.2 is our null. Now we are trying to demonstrate, we are trying to show evidence that this mean weight is not 3.2. So this isn't a specific direction. This is just the general, is it something else? So for our alternate hypothesis, we're going to say mu does not equal 3.2. That makes this a two-sided alternate hypothesis because of the not equal to. We don't really care if it's above or below 3.2. We just want to know, is it something else, anything else? Notice that there's a little bit of distracting information here, which is that sample mean. They do tell us that the sample mean is 3.68, so it can be very tempting to try to write that in your hypothesis statements, but that doesn't go there. We use that sample mean to make our calculation, which we'll do in a later video, but that sample value never goes into the actual hypothesis statements. So I can see right now that in this sample, the sample mean was higher than 3.2, but it wasn't very much higher than 3.2. It was a little bit higher. So now the question is going to become, is that enough evidence to say that we think that they're advertising this incorrectly? Or is that just kind of a fluke, random happenstance that this sample of 50 cones happened to have a slightly higher mean, but maybe if we took other samples, we would really get close to that 3.2 ounce amount. So that's where we're headed with this, but for right now, we're just working on how do we set these up.